When we look up at the night sky, it's easy to wonder what lies beyond, out there in the vast universe of which we are only a tiny part. Humanity is unbelievably small, almost impossible to comprehend when we think about the sheer scale of everything that exists beyond us. We don't even know the full size of our own universe. But does size ever truly end? Theoretically, it should. Yet new discoveries constantly challenge that belief. Size, it seems, doesn't obey the rules. From planets to stars, from galaxies to enormous cosmic walls, gravity binds everything together into ever larger structures. The question is, what is the biggest thing we've ever found, and just how big can the universe get? When we think of size, we often start with planets. But before that, we must look at smaller classifications like dwarf planets. There was controversy when Pluto was reclassified from a planet to a dwarf planet, as the term, dwarf planet, can sound like a glorified name for a massive asteroid. Pluto has a diameter of just over 2,000 kilometers, making it the largest dwarf planet we know. The largest asteroid ever discovered is Ceres, found in 1801. Located within our solar system, Ceres is about 950 kilometers in diameter, roughly two-thirds the length of the United Kingdom. Despite its size, it's still far too small to be a planet, showing how many bodies in space fall below that classification. Skipping moons for now, we move to planets, the real deal. Planets vary widely in size, composition, and number. It's estimated there could be up to 3 trillion planets in our galaxy alone. But there's a limit. Once a planet becomes too massive, it begins to behave like a star. A planet would need to be roughly 80 times the mass of Jupiter to ignite nuclear fusion and become a star. So, the largest planets can only get about 2 or 3 times the size of Jupiter. One of the biggest known is GQ-Lupi b, discovered in 2005 about 500 light-years away. It's roughly 2.5 times larger than Jupiter, though it might be much more massive, perhaps even bordering on becoming a failed star. Compared to planets, stars are where true enormity begins. Even Jupiter, the giant of our solar system, is tiny beside our Sun. Yet our Sun is itself small compared to the largest stars. Among them, the red supergiant UY Scuti stands as one of the most enormous. Located about 5,000 light-years away, UY Scuti is so massive that if it were placed at the center of our solar system, it would engulf everything out to Saturn's orbit. Light would take 7 hours to travel around its surface, compared to only seconds to circle the Sun. It's almost incomprehensible how vast it is. But even stars pale in comparison to the next level of cosmic power, black holes. These monstrous entities form when massive stars collapse under their own gravity. The largest known black hole resides in a distant quasar called TUN 618, located around 10 billion light-years away. The black hole at its center is estimated to weigh 66 billion times more than the Sun. Its size is so immense that its event horizon, the boundary beyond which nothing can escape, is about 1,300 times the distance between Earth and the Sun. This makes it an ultra-massive black hole, the largest type we know of, and a true cosmic monster. Even black holes, as gigantic as they are still small compared to the next scale, nebulae. These are vast clouds of dust and gas created by dying stars, the ghosts of once bright suns. The largest known nebula, the Tarantula Nebula, stretches about 1,800 light-years across. If it were as close as the Orion Nebula, it would cast shadows on Earth. From nebulae, we move up to galaxies, colossal systems containing billions or even trillions of stars. The largest known galaxy, IC 1101, sits about 1 billion light-years from Earth and spans around 6 million light-years across. It holds roughly 100 trillion stars. If placed at the center of our local group of galaxies, it would swallow the Milky Way, Andromeda, and several smaller galaxies entirely. Beyond individual galaxies are galaxy clusters, collections of hundreds or thousands of galaxies bound together by gravity. Our own cluster, the Laniakea supercluster, contains over 100,000 galaxies. Yet it is dwarfed by even larger formations, such as the KBC Void and the Colossus supercluster. The largest known complex, the Pisces Cetus supercluster, stretches more than 1 billion light-years across, making it one of the grandest structures in the observable universe. But even the spaces between these clusters hold mysteries. Supervoids are immense regions of nearly empty space with far fewer galaxies than expected. The largest, the KBC void, spans about 2 billion light-years, and we are inside it. Yet the most mysterious is the possible, Borealis supervoid, a strange cold region in the cosmic microwave background that may hint at parallel universes or vast regions of near-total emptiness. There are, however, theoretical limits to how large cosmic structures can get. The cosmological principle suggests that, on a large enough scale, the universe looks roughly the same everywhere. No region should be fundamentally different in structure. This means structures larger than about 1.2 billion light-years shouldn't exist. But nature seems to break even that rule. The Sloan Great Wall defies this limit. Measuring 1.38 billion light-years across, this massive filament of galaxies stretches across a portion of the universe so vast it challenges our understanding of cosmology itself. And even it isn't the largest. Several quasar groupings, such as the huge LQG, span over 2 billion light-years. The giant gamma-ray burst ring, discovered in 2015, measures 5.6 billion light-years across, an unimaginable scale. Yet the current record holder for the largest known structure in the universe is the Hercules corona Borealis Great Wall. Spanning an unbelievable 10 billion light-years, it is made up of a cluster of gamma-ray bursts scattered across an area so vast that it defies nearly all known physical theories. Scientists estimate there is less than a 1% chance that it formed by coincidence. It might represent some ancient, incomprehensible structure, the largest ever known. Even so, it is tiny compared to the universe itself. The observable universe is about 93 billion light-years across, but the entire cosmos may be hundreds of times larger, perhaps infinite. Size, in the end, may never truly end. From the smallest asteroid to the largest galactic wall, the universe keeps expanding our imagination. So next time you look up at the night sky and feel small, remember the unimaginable scale of existence, and the infinite wonders still waiting to be discovered.